So guys, we can do these in kind of any order we want, but I'm thinking I'll start like with sine, cosine, and then I'll do tangent, cotangent, secant, cosecant, or something like that. Okay? So let's start with number 2. And the things that I want you to remember about sine, okay, when you're graphing it, this is the thing you need to remember. Start at 0, goes to A. Okay? If you remember that, you should be pretty good to do this whole problem. So here's what we do. Okay, the first thing is we identify what A is. Okay, on this question, A is 2. B is the number right here. Since there's no number there, B is 1. All right? So that tells me that my amplitude is 2, and my period is 2 pi over 1. Okay, so remember with sine, it's 2 pi over B. Okay? So I start, the amplitude and period is basically just going to help me graph it. So positive 2, negative 2. Over here, you put the period. I'm going to put it at 2 pi. And then I'm going to have a space like on the test, I think, like little boxes right there for you to fill in, because I want to make sure you fill in those 3 things. All right? So let's see. You can either do half and half again, or you can just do a quarter and come down here. So like 2 pi divided into 4 parts. 2 pi divided by 4 is pi over 2. So I put that here. Okay, so I put this pi over 2. So it's 1 pi over 2, and then you just count it. So if it's 1 on the top, 1 pi over 2, 2 pi over 2, 3 pi over 2. 2 pi over 2 is just pi. 3 pi over 2, 2 pi. Okay? So that's what you do first. That's what A and B will tell you. You guys good with all that? Okay, so first step, label it. This is with sine and cosine. First step, label it. Second step, do the drawing thing where you're going to start at 0 and go to A. Okay, now I am going to be shifting this, so I'm going to like just draw it lightly or do a, dotted line, something like that. Yeah. So it's going to go, I'm going to start at 0, I'm going to go to 2. 0, 2, 0, negative 2, 0. Just draw it like a little bit lighter or dotted or something like that. Okay. You could do the whole side if you want. I guess, just like kind of follow the pattern. Okay, and now we got to shift this. And the way that I'm going to shift it, you can write your shifts here. If it's plus, that goes left, pi over 2, and minus 1 goes down 1. Then you got to look at your labels right here on the x-axis to go, okay, left pi over 2 is like 1 space to the left, right? So it's basically going to go 1 space to the left and 1 space down. So when I'm actually doing it, I'm going to go left 1, down 1. Just start wherever you want and just go left 1, down 1, and just keep doing that for all your points. Left 1, down 1, down 1, down 1. Did I miss something? Okay, so it's going to go boom, 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 and then just like kind of complete the cycle, I guess. Okay? Is there any questions about that? I think you can do that. Okay, so do the amplitude and period first, and then start at 0, go to A, and then shift it. All right, sweet. So let's look at the cosine one. Ooh, how fun. Okay. All right. A is negative 2, like that's actually A. If we ask for the amplitude, though, the amplitude is 2, because amplitude means the height of a graph, so it's always positive. But it means it starts at a negative, yeah. And then we have, this is B. What's up, buddy? Thank you. Okay. And remember, the period for sine cosine is 2 pi over B. So it's 2 pi over 2, so the period is just pi. So that's here and here. All right? And then I'm going to draw it, and then I'm going to shift it. So when I draw it, I say to myself, okay, so the way that we remember cosine is we say cosine starts at A and goes to 0. So if you try to just remember that sine is 0, 0, that's the way I remember it, and that helps me, and then cosine is like not, right? Cosine starts at the other part. Okay, so I'm going to start at -2, and I'm going to go to 0, and then I'll just follow that pattern. So then 2, 0, -2, follow that through. Draw the same thing on the other side. Right? Oh, I didn't make my label things. I don't like doing stuff out of order. Boom, boom, boom. Okay, so if I label those, I'm going to say this is, okay, pi divided by 4 is pi over 4. So that's 1 pi over 4. That's 2 pi over 4, which reduces, yeah, and then 3 pi over 4, and 4 pi over 4. Okay? And so what that tells me is, okay, so this is kind of weird. The shift is right pi and then up 1. Okay, right pi up 1. That's right. What is right pi going to actually do? So like this point right here, we'll move to that point. This point right here, we'll move to that point. This point right here, we'll move to that point. You know? It's almost like, here, I'll show you, you can visualize it, and then we'll move it up 1. But let's say I had like this whole thing here. Okay? And I'm moving it right pi. So that's pi over 2. That's pi. See how it's just going to like go back on itself again anyways. So anytime your shift is like the exact length of a period, you kind of can just ignore it. Okay? So it shifts right pi, but then the only thing I have to worry about is up 1. So I'm just going to move each of these points up 1. Yeah, it is. Bum, ba-dum, bum, bum. That makes me hungry. There we go. What do you guys think so far? Easy? Any like major questions? Like I really want everybody to just get, boom, 1,000% on this test, okay? That would be real helpful. Like literally these. Sure. You wouldn't even notice if I did, would you? Let's say same thing, different numbers. Maybe different numbers. Maybe the same numbers. I don't know. Let's do tangent next. Okay. Here's how I remember tangent. So there's two things you got to remember. For everything, there's two things you got to remember, okay? I'm going to like kind of highlight these here. Starts at 0, goes to A. Starts at A, goes to 0. Okay. For tangent, what we're going to remember is it starts at a point. So it starts at 0, 0, at the point 0, 0. And the little liney things go up. They're not lines, they're curves, but you guys know what I'm saying, right? So that's all you got to remember is point 0, 0, and then they go up. Unless we make it negative, right? Okay, so that's what we memorize for tangent. All right, tangent doesn't really have an amplitude. There is something that we're going to do with A, but we'll talk about that in a minute, okay? So A is 1, that's B. With tangent, okay, so here's what I do actually. Let's start here. All right. It starts with a point. So before I do anything else, I'm going to go point asymptote, point asymptote, point. Okay, I'm just going to do like every other one. All right? So I draw all those down. And then here's the thing. So the period for tangent, okay, won't ask you for amplitude because it doesn't really have an amplitude. But the period for tangent is pi over b. Okay, so it's not 2 pi over b anymore. It's pi over b. So you remember that? Now, you guys, what that tells you is that is the distance between every 0. Every 0 has a distance of pi over 2. It's also the distance between every asymptote. Okay? So however you want to label it, you know, you can do that. So for example, all right, if it starts at 0, the next point should be at pi over 2. The next point should be at pi. Right? Same negatives on the other side. And then I look at this and I go, okay, cool. What's halfway between 0 and pi over 2? Well, it's like halfway in between those. Pi over 4. So then I just go pi over 4. So it's 1 pi over 4, 2 pi over 4, 3 pi over 4. Like that. I'm not going to do the other side. That's enough. Okay? So the period just tells you how far between when the graph repeats itself. So either between zeros or between asymptotes. And the last thing I do is I go, okay, tangent lines go up. Tangent lines go up. Now, the fact that there's like a 1 right here, it just kind of helps me draw it. It makes me draw right here and here. I just use those as like guide points. And I draw it up. It's not like a huge deal if you don't do that. But that's what where those numbers come in. Whoa, whoa, whoa. Relax, buddy. Oh no, I touched something and started going crazy. Well, fine. There we go. And there's my beautiful tangent graph. Okay? As long as you got like a couple, 2 or 3 of them, it's fine. Alright, so the thing that we're memorizing for this one is starts at 0 and the lines go up. Okay, let's look at cotangent. Okay, so cotangent starts with an asymptote. So tangent starts with a point, cotangent with an asymptote. So that's the big difference of those. And then the little liney things go down. Lines go down. Okay? So that's how I remember cotangent. Okay, so if I know that cotangent starts with an asymptote, then I'm just going to do every other asymptote point, and just fill that in. Okay? And I'm going to do the same thing in terms of like the period. Let's do the period next. So remember, the period is the distance between asymptotes or the distance between points. Okay. So for this, the period is pi over b. This is b right here. Okay? So the period is 1, so that's weird. Whenever there's a pi in your equation, like the period goes by just like whole numbers. Which is okay. So if this was 0, what would the next asymptote be? 1, right? Because that's the period. And the next one would be 2. And halfway in between would be 1/2 and 3/2. And you could label the left side, but you don't have to. Okay? Okay, so then the last part, we know that cotangent normally goes down. It's supposed to go down, but this is a negative, so that flips it around. So instead of going down, this goes up. So we remember what it normally does, and then if I have a negative, we have to like change that, right? So that's going to go, so the lines are going to go up, even though it's cotangent. And then the 2, all that tells us is that when I'm drawing it, when I go to this point right in the middle, I go 2, -2, 2, and I go up. So I can make them a little skinnier. -2, 2, go up. -2, 2, go up. There you go. I'm probably not going to give you tangent and cotangent graphs shifted, because that's just like difficult. So as long as you're like labeling them correct and making them draw the right way, that's good. Okay, we good so far? Sorry, there you go. Whoa, whoa. Oh, with cotangent? Okay, so it goes like this. I'm going to give you like a blank graph. This is not for this graph. Let's just look at this blank graph real quick. If I'm drawing a tangent, I'll put a point, asymptote, and I'll alternate it. Okay? That's for tangent. If I'm drawing a cotangent, I'll put an asymptote, point, asymptote, point. That makes sense? And you just alternate it. So it's just remembering that tangent has a point in the middle, cotangent has a line through the middle. And then you just alternate every other one. Okay? Nice. All right. So let's do secant and cosecant. Okay, we'll look at those, and then I'll have a couple for you guys to try by yourself. So secant, cosecant. What you're going to do, like for cosecant, is you're going to do the entire thing as if it's sine, and then just draw the little parabola, guys. Okay. All right, cool. So sine. Well, actually, let me start with this. That's A. That's B. Okay, so A tells me my amplitude is 1/2 negative 1/2. My period is 2 pi over B. And so my period is just pi. Okay, and then if I want to get through here, all right, it's going to be pi over 4, 2 pi over 4, 3 pi over 4. All right, so this one doesn't like have any shifting or anything, so that's good. But this one is a sine graph. And so I say sine starts at 0, goes to A. So it starts at 0, goes to A. Okay, and you're going to draw this one like kind of dotted or something, because we have more stuff we got to do. Okay, so if that was 1/2 sine 2x, that's the exact graph, and I'm done. Now, to make it cosecant, basically, you just draw the little tangent lines and draw the parabola things. Now, look, if you don't draw the tangent lines, I mean, it's the asymptotes, it's okay if you don't draw the asymptotes. I mean, as long as you're very, very careful and you go, like, I know it's going to go here, as long as you don't go past that line or past that line. You know what I'm saying? So if you could see it and you don't want to junk up your graph with all these asymptotes, that's fine. Yeah. Yes. 100%. So you can do your own spacing right here. So just like cross that out, put 1/2, and you're good, right? Yeah, you can absolutely do your own stuff so it's all spaced out. As long as you label it, right? But yeah, so technically there's going to be these asymptotes, like there's going to be here, here. And like I said, if you want to draw them really lightly, or if you don't want to draw them at all because you can kind of see it where the grid lines are, that's okay too. And then you just connect that and go like this. So it's the same thing as sine and cosine with like one extra step at the end. Okay, what do you guys think? Make sense? All right, cool. Okay, let's check this out. Yeah, Logan. Yeah. Yep. And it's because sine, it's actually because of this right here, positive 1/2, right? So sine starts at 0 and goes to A. Not a dumb question, good question. So it would go down first if it was a negative 1/2. Yeah, perfect. Okay, so sine starts at 0, and then the way you tell which way it goes is just if A is positive or negative. So it will go up first or down first based on that. Cool. Okay. Let's do secant. Secant goes with cosine. All right, let's see here. I'm going to start with A and B. A and B. B is just like 1 right here. Okay, so A is at 3, negative 3. Again, if you don't want your graph going off the thing, like if you're like, oh my gosh, I can already tell like my little parabola guys are going to be all over the place. With this one, I might actually change it. You can actually just say, I mean, call negative 3 wherever you want. Let's call it. Well, now you do have to be a little bit careful, actually, I should say. Because I was going to say, well, let's call negative 3 right here. But then when I go to move it down 1, I can't really move it down 1 because that's not the right scale anymore. Do you guys get what I'm saying? Because I'm going by, like, whatever. So, I don't know. That one confuses me a tiny bit, so I'm actually just going to leave it. Okay, I'm going to leave it just because 3 is so awkward. I don't want to go by 3s. I don't want to go by 1.5s. I don't know. I'll just leave it so I don't screw anything up. Okay. The period for this is 2 pi over 1. If I divide everything by 4, that gives me pi over 2 pi 3 pi over 2, 2 pi. So I fill all those in. Okay, and I'm starting off by doing cosine. Okay, so I go, let's see here. Okay, cosine starts at A, and A is positive 3. If A was negative 3, it started at the bottom. Starts at A, goes to 0. Okay, I'll just like follow that along. Now, because I have to shift this is going to get kind of crazy, but I'll try to pay attention to everything that's going on. So then the shift for this is going to go, let's see here, plus left pi over 2 down 1. And if I look at my labeling right here, pi over 2 is 1 square to the left. So 1 squared left, 1 squared down. Now you guys, these mess me up sometimes. They really do. So what I'm going to actually do real quick is the down 1 tells me what the middle line of the graph should be right there. So that's like my new 0. I just think that's going to help me a little bit. So left 1, down 1. Left 1, down 1. Left 1, down 1. Left 1, down 1. Down 1. Left 1, down 1. Down 1. Okay, I'm still not done. This is still like another dotted one, but and then just like finish it through to right there. Okay. I mean, if it's really messing you up and you have to erase the first set of lines, like you can, but just remember now, I'm building my what are they called? I'm building my little parabola looking guys, okay, off of this purple graph, right? So let me make these a little bit bigger. So if I grab this here and I go like this, again, just be careful not to cross over those grid lines because that's where the asymptotes would be. All right. So it doesn't have to be perfect. Just be careful. Like if you draw it all crazy and it goes way over there and it goes past the line that it's not supposed to pass, then that would be bad. But there we go. Okay. Whew. What do you guys think? It's okay? You be able to remember all that stuff? Okay. Like, why are you saying, like, why am I asking that? Yeah, just to ask what that number is supposed to be. Right there. Okay, so I want you guys to try this. There's a sine, a secant, and a cotangent. So there's like kind of, 3 more. I want you to try those by yourself. And then we are going to have a little section on using your best friend chart. Just because I definitely really want you guys to remember that, how to do all that. So we'll probably have a little section on using your best friend chart, and then we'll read the graphs and try to make equations. Okay? But why don't you do these 3 real quick? Okay, up through number 9, and then we'll go over those. Obviously, if you're done, you can keep on going, but go up through number 9.
What's the period for again?
Okay, cool. So let's go through the steps. So A is going to be -2, but the amplitude is 2, right? So A can be positive or negative. Amplitude, we just put whatever the number is. I'm just going to go ahead and stick it right here. You guys can put it wherever you want. Okay. B is 3, so the period is 2 pi over B. Now, this is one that's slightly harder to find all these spots in the middle here, okay? I mean, it's not that bad. It's just a little bit harder, but here's how I do it, okay? I take the 2 pi over 3, and I want to divide it up into 4 parts, right? And then I go, okay, well, dividing by 4 is the same as multiplying by 1/4. So that gives me 2 pi over 12, which I reduce as pi over 6. So my numbers are going to be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. And I just reduce them as I go. So that'll be pi over 6. 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. And then 2 pi over 3. Okay? The other way people like to do that, and it might work a little bit better on this one too, is take this, cut it in half again. But then you guys still have to label them. You still have to find the one and the third one, you know. Okay, so that's how I do all that. This one does not have an up-down shift. Oh, no, it does. Sorry. It has a down one. It does not have a left-right shift, okay? I'm going to draw the first one without the shift. Because it's sine, it starts at 0, goes to -2. Okay? And then I'll draw the actual one that's just like down one from that. All right? Which is literally like, oh yeah, and it went down first because it was negative, right? There we go. Okay, guys good about that one? Hey, best friend, how are you? Wait. My kids are trying to teach me how to do this one. I don't really know how to do this one. Like that, right? I'm so dumb, I can't do it. Like that. Bro, I can't. Bro, I can't. Look at that. Why is it so hard? You could. Oh, middle finger. Adam. Yeah, okay. Bro, why can't we just do that like we used to do? Huh? Okay, yeah. Oh, look at me. Oh, it's very difficult. Oh, because it's hard to keep your pinky next to your ring finger. Ow! My arthritis. Just kidding. I'm not that old. All jokes. All right. Cosine. Okay, let's do this. All right. A is 2, and amplitude is 2. Okay. B is 1/2. And since the period, okay, is 2 pi over B, it's 2 pi over 1/2, which is 2 pi times 2, which is 4 pi, which is lovely because it divides up really nicely. Okay, divide that by 4 is just pi, so it's pi, 2 pi, 3 pi. Sweet. Okay, this is a cosine graph. So cosine starts at A, goes to 0. Oops. Oh my gosh, why am I so dumb? All right, cool. This one has no up, down, and no left, right. So the only thing I really need to do then is add my little guys here, which would look like this. And don't cross over the things, okay? If you want to draw the stuff so that you don't cross over them, it's not a bad idea. If that helps you. Wherever it hits 0. Boop. Okay? So I can draw that one. Draw that one. On the outside, I mean, you can draw like a little halfy line. You can draw the whole thing. I don't really care. As long as I can see what you're doing. Okay? So beautiful. All right. So then we'll do a tangent one. Okay. So this one is like, okay, A is -2. Technically, right, the amplitude is none because cotangent doesn't have an amplitude, even though we do use A. B is 3. The period, remember, for tangent, the period is pi, tangent and cotangent is pi over B, not 2 pi over B. So the period is pi over 3. Now I do this one differently. I don't start and label the ends. I do this differently. I decide if it's going to be a asymptote first or a point first. Since it's cotangent, there's an asymptote. So I go asymptote point, asymptote point. Okay? Just alternate every other one. All right? So now we got to label some stuff. So the period is pi over 3, which is going to be, again, it's going to be like the distance between here and here. So if that's at 0, what's the next asymptote at? Pi over 3, right? Okay, so if that's 0, that's pi over 3, that's 2 pi over 3. And then halfway between 0 and 1/3 is like 1/6, right? So that's pi over 6. Then what's this one right here? Okay, if it's like 1 pi over 6, 2 pi over 6, which reduces 3 pi over 6, which is pi over 2. Yeah. 3 pi over 6, so that's pi over 2. Okay, you don't really have to put the negative one. Sometimes I put that one. Cool. And then I go like this. Cotangent normally goes down, but because it's a negative, this one is going to go up, right? And so I put this little thing at -2, +2, and I go up. That's not like that big of a deal, just like kind of partway in between, just -2, +2, -2, +2. Okay? Yeah, and this one didn't have any left, right, or up, down. Nice. You guys good? Okay, let me remind you about this stuff. Right? There's just going to be a handful of questions like this in radians, just to make sure you don't remember that you all remember. Okay? For that, use your green chart. Yeah? So find your green chart. Let me plug this in. All right, let's do it again. So step 1, you draw it. Make sure you know what quadrant it is. Step 2, you look at, and I think I'm going to put them all in radians because those are really the like ones that are really important. You look at what radian value it is. This is pi over 4. Look at your chart. So on your chart, go to pi over 4, go to cosine. What does it say? Very good. And then the last thing you're going to do is ASTC. It's in the sine quadrant, so cosine is negative. Okay? Does that make sense? So then, yeah, my answer is just -√2 over 2. Here, bro, I got you. And I'll let you, I'll put it up here so you can, like, copy it down real quick. Yeah. Okay, yep, so all the way around in quadrant 4, pi over 6 is 1 over √3, and then we go like this. ASTC, that's the cosine quadrant, so this is negative. All right? Now, when we start doing like a reciprocal function like secant, okay, what I'm going to do is I'm actually going to do cosine, and then I'll just flip it. Okay, I'll reciprocal it, right? Now, the other thing is 3 pi over 2, you guys, is the point on the graph. It's actually 3 pi over 2 is right here. Okay? And so in order to know what that point is, it doesn't come off the chart. It comes off the thing that has like all the ones and zeros. And so if you look at this, it's like down here. And cosine is the x coordinate. Okay? So cosine of that point is 0. So I come back over to here. Okay. The cosine of 3 pi over 2, because this is a point 0.1, is 0. So that tells me that the secant of 3 pi over 2 is 1 over 0, which is undefined. Okay? A couple of people, I don't know if it's in this class or another class, I just let me show you this, like, write their zeros like that. So don't do that because that technically means undefined. It means like the empty set, you know? Well, when it's that, it's theta. When it's that, it's undefined. So, like, weird. But it doesn't mean 0. So if you, like, naturally write a little line in your 0, try not to do that. Because then you'll get confused. Or I'll get confused, I'll say. Okay. A negative angle tells me this goes backwards 2 pi over 3. That gets me right there. I look at my chart. The sine of pi over 3 is what? Root 3 over 2? And then this is in the AST quadrant, so that's negative. Okay, so Logan, you guys do this, okay. So do you understand where the angle comes from, where I drew it? The negative. Okay, so the last thing you do is you say, okay, all are positive here. So if I had drawn it here, all would be positive, okay? Oh, this is what you don't understand. The root 3 over 2? Okay, cool. So 2 pi over 3 has a reference angle of pi over 3. Okay? So no matter what the top number is with radians, you just look at that. This one, I'm going to look at pi over 4. So it's pi over 3 and it's sine. So this is why I have my chart next to me. So sine pi over 3, I just pull that number right there. So all those come from the chart. So that's instead of memorizing the whole unit circle, we just use our chart. Yeah, for sure. So see how like each of these are like pi over 6, pi over 4. I just look at that chart, right? So yeah, so yeah, exactly. So let's see, this one was, yeah. Okay, so yeah, this next one, okay, so for cosecant, I'm going with sine. I'm looking at pi over 4. Sine of pi over 4 is root 2 over 2. Cosecant is 2 over root 2, which you don't have to rationalize, I don't care. And it comes all the way around to that side, right? 7 pi over 4 is all the way around there. So I go ASTC, that's the cosine quadrant, so that one's negative. Geez, I made every single answer negative. Weird. Okay? Does that stuff make sense? You guys can go back and look at like your module 6 review if you need to study that or whatever. I think I got some notes online, but you got that. And the last thing, we're going to write some equations. Ooh, there's 6. What's your bet? There's like 1 of each. Okay. Take a look at this, guys. Which of these, let's do them like this. Which number do you think is the graph of sine? One of those two. Yep, it's the first one. How do I know that's sine? Because it starts right in the middle. Okay? All right, cool. So yeah, 2 sine. Now, the way that you find b, there's a little trick to finding b. I've showed you guys this. But because these graphs always go out to 2 pi, so this thing, you know how the period is 2 pi over b? B means how many cycles it can make before it gets from 0 to 2 pi, like how many full cycles. So if I count these cycles, look, 1, yeah, 2, 3. Okay? As long as you start always in the middle, you won't have to do a left-right turn or a left-right shift. And this doesn't do an up-down shift either. So that's it. Just 2 sine 3x. Okay? So this one is going to be cosine because it starts up here. So this is cosine. And because it starts at the top of a curve, it's a positive cosine. Okay, now, when it's like shifted off center like that, this is what I usually do, so it doesn't confuse me. I draw a line right through the middle of it. So see how like that's the bottom, that's the top, that's right through the middle. Okay, you guys see that line? So now that I drew that line right through the middle, what's the amplitude of this graph? Let's talk about amplitude first. How high, how low? Yep, because it goes up 2, down 2, right? Amplitude also, if you count the total height, is just half of it, okay? So yeah, when I look at this, I'm like, okay, that goes up 2, that goes down 2, that's 2. Because it starts up here, it's positive. If I had a cosine graph that started right here, that would be negative. Okay? Okay, B. How many cycles does this make from 0 to 2 pi? Nope, not even. half a cycle. See that? It doesn't even make a full cycle. A full cosine goes all the way up, all the way down. So it actually, yeah, it makes half a cycle. Okay, and now remember we had this line here? Wherever that middle line is, that's how it moves up or down. So it doesn't have to move left or right. As long as we pick this point in the middle, we're chilling. But that middle line is supposed to be in the middle. It is 0, and it's not. It's down here. So then that's how I put -2. Okay? So whatever the middle line is, that tells you the up or down. Right? So if I look at, like, so for example, if I just go draw those middle lines, like there's one, so I know that's down 1. Right, -6 and 2. I think that middle line is like right there. Okay, so that middle line will kind of help you. All right, let's look at 17 next. Is it, okay, let's draw the graph of this. Is this sine or cosine? Sine goes down first, so it's -2. Oh, 2, right? The amplitude is 2. And it's sine, which is cosecant. Cool. Okay, okay. Yep, and that's it because, yeah, how many cycles does it make in one period? That's 1 cycle. You don't have to write the 1. You can if you want. And then it moved -1 because that's where the midline was. All right? Cool, cool. Not bad, not bad. All right. Yeah, for sure. Okay, so, actually here, let me write this real quick. Okay, so when you're looking, you're always looking in the middle, like you want to look right along this axis right here, okay? Now it might be shifted up or down, so I'm not going to put that there. It might be shifted up or down, but no. Okay, if it goes like this, and it starts in the middle of the graph and it goes up, that's positive sine. Okay? Yeah, because it starts there. If it goes like this, so it starts in the middle, but it goes down first, that's a negative sign. Okay, if it starts like that and it's up on top, but see how it's not in the middle, it's on like one of the peaks? That's a positive cosine. And if it starts like that and it's down there, that's a negative cosine. So then when you see the parabola things, yeah. So when I'm just looking at this, I'm like, okay, so see how it's in the middle, it goes up, positive sine. On the top, that's positive cosine. In the middle and goes down, that's negative sine. And it's still on the top, that's positive cosine. And then you just have to switch it if it's the parabola one. So that's where the cosecant comes from. The amplitude is how far it goes that way and that way. So that's 2. And because it went down first, it's negative. Cool. 1 full cycle, so it's 1x shifted down 1. Okay, so let's do this one, and then we'll go back and do the tangent cotangent. Okay, that's a cosine graph, and since it's starting on the top of the mountain, that's a positive cosine, which actually is positive secant. I often mess that up. I put cosine instead of secant, so I remember. So it's secant. Okay. What's the amplitude of this? This goes up 4, down 4. The way I knew where to draw that line, I was like, oh, what's right in between -6 and 2? -2. And then it goes 4 in each direction. So the amplitude is 4. It's positive because it starts on the top. How many cycles does this make? From 0 to 2 pi? Half a cycle. And then this line that I drew right through the middle is down 2. Okay? Not bad, right? Okay, now let's look at tan and cotan, you guys. Which of these is tangent? I would go with that because there's a point in the middle, that's right. Okay? For these, I don't really think I'm going to change the number right here because literally it's just too hard to tell. I don't know, maybe. I think it is 2, you're right. If I go halfway through, it looks like it's at 2, right? Now, here's the thing. Tangent's supposed to go up. That one's not going up, it's going down, so it's negative. So you gotta like really look in here. Okay, so it's like, if I draw, okay, hang on a sec. Here's my point. I'm gonna like, just so you can see it a little bit better, put the asymptotes here. Draw that if you want. Okay. Now, halfway between there and there, you kind of see where it touches. And it's right there. So that's why. And then like halfway between there and there, it's at 2. That's a little like more difficult, but yeah, that's where that comes from. To look. Okay, and then because it goes down, it's negative. Now, the period on these, alright, what you have to do is measure the distance between either 2 asymptotes or 2 points. It doesn't matter. So what's the distance from, like here? What's the distance from 0 to pi? Pi, right? Or the distance from negative pi over 2 to pi over 2 is pi. So you just do this little equation, right? You go, okay, pi over b was pi. So in this case, b equals 1. That's like pretty easy. So instead of counting this, you got to find the distance between and just go, okay, that's 1. All right. Now this one, I'm going to say that this one is cotangent because it starts with a line in the middle, right? And then like, okay, so see how, okay, so, yeah, so see how like halfway between the asymptote and the point, right there at pi over 2, it comes up right here, and it's 1. And cotangent is going down, and it's supposed to go down, so it's positive 1, right? So the only thing that's a little bit weird on this one is the period, so check it out. What is the distance between asymptotes? 2 pi. So you gotta go like this. Pi over b equals 2 pi, and figure out what b has to be. 1/2. Some of you better look at it and tell, like, okay, that's gotta be 1/2 to get to 2. You know? If you can't just look and tell, just go like that. Put that over 1. Cross multiply, right? 2 pi b equals 1 pi. Divide by 2 pi. Pi's cancel out, so b is 1/2. And then that's it. So really, we're just kind of changing a, b, and telling if it's positive or negative on those. Make sense? Cool, cool. All right, yeah, let's go. All right, let me pause this.